Okay, we're going to look at another way to be able to find the volumes of revolutions. This is referred to as the shell method. Basically, if you take this kind of pinkish rectangle right up here, rotate it about the x-axis, it would sweep out this cylinder with the middle part missing. In other words, the volume of this cylinder would really be the volume of the whole big cylinder minus the inside, which for the most part is going to be your thickness here times how far it is around, which is perimeter or circumference 2 pi r, times how high or the height of your cylinder. Well, for the most part, if we look at just your average height here, or I mean your average radius, we could approximate the volume of the cylinder just by using your if I can talk here, average radius versus the inner and the outer radiuses and subtracting them. So for the most part, it really just boils down to going 2 pi r, where once again r is that average radius. In the context of your diagram down here, that's p of x, how far you are from the x-axis, times h of x, and that's your height of your function. The 2 pi r is once again the volume or the perimeter circumference, your average height. This is your thickness, integrating from A to B. Well, if you're revolving it the other way, then it ends up being this here just in regard to y's instead of x's. Once again, the P is still your average radius, and this is your height. So let's go ahead and take a look at this. This is a shape that we are trying to find here. We're revolving this around the y-axis and kind of forms a donut with the middle almost gone. Here's an animation of our shape that we're looking for. So I'm not sure if that helped you at all or not, but hopefully it did. Well, since we have vertical rectangles here being revolved around the y-axis, notice your rectangle here is parallel to your y-axis, the axis of rotation. We're going to integrate then with respect to x, so we're going to go from 0 to 1 of your radius, which is how far out this is, which is just x out, times your height, which is just the height of your function, which is an x minus a x cubed. And well, all we're going to do is integrate this, so we'll distribute through our x, integrate each piece, evaluate that, and get our answer being 4 pi over 15. Now, how do you know when to use a shell or a disc, or a washer disc versus a shell? If your rectangle that you're looking at is perpendicular to your axis of rotation, notice your axis of rotation is going up and down, your rectangle is sideways. Here, rectangle's up and down, axis of rotation is sideways. If they're perpendicular, you want to use a disc or a washer method. However, if your axis of rotation goes up and down, your rectangle goes up and down, you want to use a shell because they're parallel. Or if you're horizontal and you're horizontal, you once again want to use a shell. So taking a look at this one here, we looked at this one in our last period, but we're going to look at it in a slightly different form here. Now here our rectangle, we're going to say is up and down, being revolved around our y-axis, so it's parallel. So we're going to try using our shell method here. Here's your basic formula. How far over you are here is that average radius, which is just x units over, times your average height, or not average height, the height, which is your function, which is a x squared plus 1. Now you're integrating with respect to x's, so it's going to go from a 0 over to a 1. And all we have to do is evaluate that. So distribute through, integrate. And so we get the same answer as we did before. Now, to refresh your mind, how did we do it before? That's what we have down below here. But then it has to be as two separate integrals, and it's a lot more of a challenge, but you get the same answer. So some problems can be done with discs and washers or shells. One way is sometimes easier than the other way. So let's take a look at this one here. So we're going to basically look at this with our horizontal axis and our vertical axis. And we have our curve of a 1 minus an x squared over 16. Now, this one here is going to be easier if it's worked out using discs. And you can see that down here. If you would take a little vertical rectangle and it would be going around your x-axis, it would form a disc. Well, some things are easier with shells, others are easier with washers or discs. This happens to be one that's easier with a disc. So just to refresh your memory on how to do that. Also here you'll notice our rectangle is perpendicular to your axis of rotation. That's another reason why it's a disc. Remember for your disc you go pi, integrate from -4 to 4 because you're going from -4 all the way over to +4. And then it's normally pi r squared because that's the area of a circle. So you got to go your radius squared times your dx. Your radius is your height here, which is your function of a 1 minus an x squared over 16. You have to go ahead then and FOIL that out. Then you can go ahead and integrate each piece. Then all you want to do is evaluate that. And you get 64 pi over 15.